integration of 1 divided by root x squared plus 1. Starting with problem 1, integration for x divided by root x squared plus 1. Okay, so the point here is, where is the main function, where is the inner function, where is the derivative of this inner function. So write this function to be times x dx. This may clarify to some extent where is the function x squared plus 1, where is the derivative of this inner function, which is x. Okay, so now reformulating this function to be integration of x squared plus 1 to the power negative half times x dx. Now we have a function integration for some function to the power n, and the derivative of this function exists, dx. This equals to the function to the power n plus 1 raised the power by 1 and divided by the new power plus c. Okay, so following the same idea here, we need the derivative of x squared plus 1. What's the derivative of x squared plus 1? This is simply 2x. Then just multiply by 2 and divide by 2. At this moment, raise the power by 1. Don't forget this half. Raise the power by 1. This x squared plus 1. Negative half plus 1, this half, divided by 1 over 2 plus c. The idea of problem 2 is different to some extent from the idea of problem 1. How come? Here we have x squared plus 1 in the denominator, which is power to 1. Here's the inner function, and this inner function is power to 1. So we are looking for the derivative of this function. X squared plus 1, its derivative is 2. So, and already here we have only x, then just multiply by 2 and divide by 2. So we can write this function as, or we can write this integral as integration of 1 over x squared plus 1 times 2x dx. 1 over some function times the derivative of this function. 1 over some function times the derivative of this function. It's equivalent to the rule. We have integration of 1 over some function times the derivative of this function dx. This equals to ln of this function plus c. So the integral here will be half ln x squared plus 1 plus c. Here we have integration of 6x squared divided by 2x power 3 plus 7 to the power half. The same idea, which is splitting this function into two functions to clarify where is the function, where is the main function, where is the inner function, where is the derivative of this inner function. So it's 1 divided by 2x power 3 plus 7 to the power half times 6x squared dx. Okay, and we can continue by rewriting this function in the denominator to be 2x power 3 plus 7 to the power negative half times 6x power 2 dx. So we have a function 2x power 3 plus 7 with the power negative half times the derivative of this inner function, the derivative of this inner function, the derivative of this yellow function, the derivative only of the yellow function, the derivative of this yellow function is 6x squared. So simply raise the power by 1 and divide by the new power. This 2x power 3 plus 7, raise the power by 1, negative half plus 1, this half, and divide by the new power plus c. In problem 3, this x power 3 divided by the cubic root of x squared plus 4. So I think that we can follow the same approach that we did in problem 1. We have an inner function which is x squared plus 4. Its derivative is x. But already here we don't have only x, we have x power 3. So we can split this x power 3 to be x times x squared. Then it will be integration of x squared divided by the cubic root of x squared plus 4 times x dx. And then already we have a function which is x squared plus 4 with the derivative of this function which is x. But what about this x squared? We can adjust this x squared to be the same as the denominator. How come? By writing it in the form integration of x squared plus 4 minus 4 divided by the cubic root for x squared plus 4 times x dx. And then splitting this function into two functions. The first divided by the cubic root minus 4 divided by the cubic root 2. So this will be integration of x squared plus 4 divided by the cubic root of x squared plus 4 minus 4 times 1 over the cubic root of x squared plus 4 all times x dx. X squared plus 4, x squared, its derivative is 2x. So we need to multiply this x by 2 and divide it by 2. And now split this integral into two integrals. This equals to half integration x squared plus 4 divided by the cubic root of x squared plus 4. In general, x divided by the cubic root of x, this equals to x to the power 2 over 3. So here for this fraction, we can write it as x squared plus 4 to the power 2 over 3 times 2x dx. It's for the first term. For the second term, minus 4 times half, it's minus 2. Integration of 1 over the cubic root of x squared plus 4 can be written as x squared plus 4 to the power negative 1 over 3 times, don't forget, 2x dx. Now we can integrate directly. Here we have inner function x squared plus 4 power 2 power 2 2 over 3 with the derivative of this function, which is 2x. The same here, we have 2x, which is the derivative for x squared plus 4, which is power 2 negative 1 over 3. So just raise the power by 1 and divide by the new power. It's half x squared plus 4 2 over 3 plus 1, this 5 over 3 divided by 5 over 3 minus 2 x squared plus 4 negative 1 over 3 raised the power by 1, this 2 over 3 divided by 2 over 3 plus c. In problem 5, it's integration of e to the power x times root 1 plus e to the power x dx. What if we write this function to be integration 1 root 1 plus e to the power x? I will write it as 1 plus e to the power x all to the power half times e to the power x dx. Now we have a function which is 1 plus e to the power x to the power half, and the derivative of this function exists. So simply raise the power by 1 and divide by the new power. 1 plus e to the power x to the power 3 over 2 divided by 3 over 2 plus c. Here in this function, I think it's proper to think about the integration of exponential function, as we have as a part of the integration exponential form 3 to the power 10x. Already we know that in integration for a to the power x dx, this will be a to the power x times 1 over ln a for sure plus c. But what if we have integration of a to the power some function times the derivative of this function dx? This equals to a to the power of this function times 1 over ln a plus c. How can we find the derivative of tan x? How we can find the derivative of this exponent, which is this exponent dash? How can we do that? Okay, thinking about that, we can write the denominator 1 minus sine squared. We can switch it to be 1 minus sine squared equals to cosine squared x, as we know. So this 3 with the exponent tan x times 1 over 1 minus sine squared, which is 1 over cosine squared x dx. Okay, what about okay, now what about 1 over now what about 1 over cosine squared x? 1 over cosine squared x is 6 squared x. So this integration of 3 to the power 10x times, replace this 1 over cosine squared by 6 squared x dx. Now we have main function, which is 3 to the power 10x. So 10x is the inner function, and the derivative of this inner function is 6 squared x. So simply the integration of this function will be 3 to the power 10x times 1 over ln 3 plus c. Integration of sine inverse x divided by root 1 minus x squared. To understand how can we evaluate this integral, so my advice is step 1, split this function into product of two functions. The first one is sine inverse x times 1 over root 1 minus x squared. Sine inverse x is the first function. 1 over root 1 minus x squared is the second factor, this is the second function, dx. Okay, so now the sine inverse x is power to 1, which means that we are dealing with a power function with the derivative of inner function, with the inner function طبعا sine inverse x, and the derivative of this inner function is 1 over root 1 minus x squared. Then simply raise the power by 1 and divide by the new power. The sine inverse x to the power 2 divided by 2 plus c. The same here is problem 9. Problem 9 is the integration of root sine inverse x divided by 1 minus x squared. So we can reformulate this function to clarify where is the main function, where is the inner function, where is the derivative of this inner function. So we can write this function to be sine inverse x, but here this to the power half times 1 over root 1 minus x squared dx. Now we have a function which is sine inverse function, power to half, and the derivative of this function, which is 1 over root 1 minus x squared, exists. So simply raise the power by 1 and divide by the new power. The sine inverse x to the power 3 over 2 divided by 3 over 2 plus c. Back again to the integration of the exponential functions. Here we have e to the power 2 cosine x times sine x dx. Okay, already we know that in the derivative of cosine x is negative sine x. What if we have 2 cosine x? This is 2, the derivative of 2 cosine x. This will be 2 multiplied by negative sine x. So I think that it's easy to conclude that we will multiply by negative 2, multiplying by negative 2 and divide by negative 2. Here, this negative half, integration of e to the power 2 cosine x times negative 2 times sine x dx. Already we know that if we have integration of e to the power x dx, this equals to e to the power x plus c. So if we have the integration of e to the power some function times the derivative of this function dx, this equals to e to the power of the function plus c. So in this case, here we have negative half constant out of the integral. Integration of e to the power cosine times negative 2 sine would be simply e to the power 2 cosine, 2 cosine, and its a derivative. Its a derivative exists, which is negative 2 sine, negative 2 sine. This will be e to the power 2 cosine x directly. Now, by thinking of this integral, here we have sine 3x divided by cosine 3x. Already we know that in the derivative of cosine is negative sine, as we mentioned before. So simply multiply by negative 3 in and divide by negative 3 out. So as we know, if we have the integration of 1 over some function times the derivative of this function exists, this equals to ln of this function plus c. So the integral here will be, negative 1 over 3 ln of the denominator, which is cosine 3x plus 1 plus c. Here we have a product of two functions, x squared times 5 with the exponent negative 2x power 3. So by rearranging these factors, we can write this as 5 to the power negative 2x power 3 times x squared dx. So we have exponential functions with the exponent negative 2x power 3. So we need the derivative of this negative 2x power 3. Then just multiply by the derivative here is negative 6x squared. Just multiply by negative 6 and divide by negative 6. So the integral in this case will be negative 1 over 6, 5 to the power negative 2x power 3 divided by ln 5 plus c. Okay, now how can we think about the integral of this function? Here we have x divided by cosine square x power 2. So we are looking for a function and inner function and the derivative of this inner function. I think that it's clear we have here x and x squared, and from this note we can conclude that in the inner function here is x squared and the derivative of this inner function here is x. But what will be the main function? The main function is 1 divided by cosine square, and this 1 divided by cosine square we can reformulate it to be sec square. Okay, so it will be sec square x as a function of x power 2 times, don't forget this x in the numerator, dA dx. As we know, the integration of sec square with only x dx, this is tan x. But what if we have the integration of sec square function times the derivative of this function dx? This will be tan of the function plus c. So this means that in here we need the derivative of x squared, which is 2x, just multiply by 2 and divide by 2 to say that in the integral of this function is half tan x power 2 plus c. Here in problem 13, we have a fraction form. In the numerator, we have root 2 plus ln x. In the denominator, we have x. To be able to understand how to evaluate the integration of this function, as I mentioned before, split this function into product of two functions. This is the first one, 2 plus ln x. The second one is 1 over x dx. After this step, I think it's clear how to evaluate this integral. This 2 plus ln x can be written as 2 plus ln x to the power half times 1 over x dx. Function 2 plus ln x with the power half, and the derivative of this function 1 over x exists. So just raise the power by 1 and divide by the new power. It's 2 plus ln x to the power 3 over 2 and divide by the new power 3 over 2. What about this function? Here we have 1 over x times ln x. How can we evaluate this function? Do the same as we did before, which is split the function into product of two functions. Can be rewritten as 1 over x times 1 over ln x dx. Okay, ln x. What's the derivative of ln x? Ln x, simply its derivative is 1 over x. And here already this 1 over x exists. So it's proper to rearrange the function 1 over ln x times 1 over x dx. Integration for 1 over function times the derivative of this function dx. This equals to ln of this function plus c. So the integral here will be ln x plus c. Here, split the function to be integration of ln x times 1 over x dx. This function to the power 1 with the power 1 times 1 over x. So just raise the power by 1 and divide by the new power plus c. Here for this function, do as we did before, integration of 1 over x times 1 over root ln x dx. We can rearrange this product to write it as integration 1 over root ln x can be written as ln x to the power negative half times 1 over x dx. Just raise the power by 1, this ln x to the power half, and divide by the new power plus c. Now in problem 17, this is integral with a new idea. It's integration of x squared minus 1 over x all to the power 6 times x to the power 8. As we know, we are looking for here a function with an inner function and the derivative of this function. But if we are thinking about x squared minus 1 over x is the inner function with the power function 6, but we don't have the derivative of this inner function here. We don't have the derivative of x squared minus 1 over x. X squared, its derivative is 2x. 1 over x, its derivative is negative 1 over x squared. And does not exist here. Okay, so how can we think about this? What if we unified this power with this x power 8? How come by splitting this x power 8 first into product of two functions, into x power 6 times x power 2. So this will be integration of x squared minus 1 over x as it is to the power 6 times this x power 8. We will write it as x power 6 times x power 2 dx. And now unify the function with the same power. Rewrite this function under the same umbrella of x power of the power 6. So this will be integration of x squared minus 1 over x times x all to the power 6 times x power 2 dx. Okay, so what's the benefit from this action? Here, x times x squared, this x power 3, x times 1 over x, this is 1. So this is the new form of the function. It's x power 3 minus 1 to the power 6 times x squared dx. Now we have a function which is x power 3 minus 1 with the power 6. We only need the derivative of x power 3. Already the derivative exists, x squared, but we need 3. So just multiply by 3 and divide by 3. So simply raise the power by 1 and divide by the new power. And don't forget this 1 over 3 here. Then this will be x power 3 minus 1 to the power 7 divided by 7 plus c. Now in problem 22, here we have 1 over root x times e to the power root x dA dx. Doing the same traditional step, which is split this function into product of two functions. 1 over root x times 1 over e to the power root x dx. Or we can rewrite it as integration. This 1 over e to the power root x can be written first as e to the power negative root x times 1 over root x dx. Okay, so we have a function, exponential function, with the exponent negative root x, and the derivative of this function exists. Part of the derivative of this function exists, which is 1 over root x. So we only need the derivative negative and 2, which is negative 2 out, which is equivalent to negative 2 out. Okay, so now I think the integration here now will be clear. It's negative 2 e to the power negative root x plus c. For this function, integration of 10 squared x divided by 6 squared x. So here we need to think about a relation between 10 squared and 6 squared. As we know from the lecture that in 1 plus 10 squared, this is 6 squared. So this 10 squared can be written as 6 squared x minus 1 divided by 6 squared x dx. That can be written as 6 squared x divided by 6 squared x minus 1 divided by 6 squared x. 6 squared divided by 6 squared, this is simply 1. 1 divided by 6 squared, this is cosine square. So the integral here will be integration of 1 minus cosine square x dx. Okay, 1 minus cosine squared is sine square, as we know. So how to evaluate the integration of sine square? Transform the sine square into the double angle rule. Half integration of 1 minus cosine 2x. This equals to half constant out of the integral as it is. What's the integration of 1? This is x. What's the integration of cosine 2x? This is sine 2x divided by 2 plus c.